Okay, good day everyone. So for this video, we are going to discuss the paper 3, okay, the February March 2022 paper 3 2. All right. So let's have a look for the first question. So first question, they give us the inequality that involve the modulus function. So they want us to solve it. All right. So for this question, both sides also have modulus. Therefore, we are going to square both sides. All right, so we are having 2x plus 3 square greater than, don't forget, you also have to square the 3. All right, because we are going to square the whole equation. Therefore, we are having 4x squared, 12x plus 9. And then we're having x squared plus 4x plus 4. Okay, so we try to do a little bit more simplification for this inequality. All right, so I'm having 4x squared plus 12x plus 9, which is greater than 9x squared, 36x plus 36. Okay, so to solve this inequality, I try to group all the terms to one side. All right, so if I group all the terms to one side, you will see that we actually can get the quadratic inequality, which is 5x squared plus 24x, then plus 27, and it is smaller than 0. So from here, I realize that I can factorize the quadratic equation. So after I factorize this quadratic expression, right, I will get 5x plus 9 and also x plus 3, which is smaller than 0. So our critical value, okay, our critical value x will be negative 9 over 5 and also x equals to negative 3. So to decide which is the part that we want, generally you can decide it by using various methods. All right, so for me, I'm using the number line. So for number line method, I'm going to draw all the arrow to the right side. And from here, you can see that this is positive, negative, and also positive. So for this question, we are looking for smaller than 0. So smaller than 0, it means that we are going to focus on the negative value, the negative part. So the negative part for this expression would be this one. All right, so from the number line, I can see that the inequality, okay, answer will be x from negative 3 until x equals to x smaller than negative 9 over 5. So it means that when x is having the values within this range, right, then the whole expression here will be a negative value. So this is how we actually solve this question number 1. Okay, so let's discuss question number 2. All right, so on the sketch of Argand diagram, right, they want us to shade the region where the point represent the complex number z satisfying these two inequality. All right, so for the first inequality, generally you can see that this should be a circle. All right, the locus should be a circle, and I would like to rephrase it become z minus a complex number. Okay, so plus 2, when I want to have a minus in front, that will become negative 2. So that when you multiply the negative inside, you still have the plus 2, right? So I'm going to rephrase it become z minus a complex number. So this complex number should be negative 2 plus 3i, and it is smaller equals to 2. So from here, you should actually know that this is the radius of the circle, and this is actually the center of the circle. Okay, all right. And then you can start sketching it if you want. So we will start sketching it here. So please take note that when you want to sketch the diagram, it will be good if you can try to draw the ratio as accurate as possible. All right, so I'm having negative 2 here. So that's why I try to plot, okay? Then in the exam, you can use the ruler to measure the length. So I'm having this negative 1, this is negative 2, and then I'm having 1, 2, and 3 here. So which means that my center will be around this at this part. Okay, so my circle will pass through 0, 3. My circle will pass through also negative 4, 3 because the radius is 2 units. Then circle will pass through -2 and 1, then -2 and 5. All right, so this will be how my circle look like. Okay, so of course my circle, the circle that I'm drawing here is not circle enough. All right, so you can try to circle it nicely, and then if you want, you can try to label this. This is actually the R. And after that, for the argument Z, smaller equals to 3 pi over 4. Again, I want to rephrase it become argument Z minus a complex number. So the complex number here will be 0 plus 0i, and it is smaller or equals to 3 pi over 4. So for this 0 plus 0i means that it is actually the reference point for me to start sketching this locus. All right, so this is a 0, 0, right? So on the right hand side of 0, 0, I imagine that there's a horizontal line here, and I want to measure from this horizontal line 3 pi over 4 units. So 3 pi over 4 unit will be going to this direction. And you need some small knowledge here about the trigo, because we know that for tangent pi over 4, when we draw a triangle, right, it is equals to 1. So that means if let's say this is pi over 4, the unit should be 1 and 1. Okay, and now we are having this angle, which is 3 pi over 4. So that means for our line that we want to sketch, right, it will pass through 0, 0. It will also pass through the 1 and 1. All right, so my tangent will look something like this. It will pass through 1, 1, then -2 and 2, then -3 and 3. So if you try to connect the points together, my graph will look something like this. So this one is actually for the argument Z. Okay, smaller equals to 3 pi over 4. So let's have a look for the shaded area now. Okay, so for the shaded area, right, for the first one, we know that the area should be bounded inside the circle because we are having smaller equals to 2. So the radius of circle is equals to 2. Therefore, smaller or equals to 2, that means we have to shade the area inside the circle. Then at the same time, for this part, they want us to sketch the area which is smaller equals to 3 pi over 4. So for this angle, it is 3 pi over 4. Okay, so if let's say they are asking for the smaller angle, the angle which is smaller than 3 pi over 4, it will be the whole region from here until here. Okay, all right. So how we know that all the region from that I shaded just now is smaller equals to 3 pi over 4? It is because of from here to this part, the argument that we have should be from 0 to negative, should be from negative pi to 0. All right, so negative pi to 0 actually also smaller equals to 3 pi over 4. All right, then for the line, okay, for this part of the area, we know that this argument will be from 0 until 3 pi over 4. So that means when I shade any point on this area, okay, the argument is smaller than 3 pi over 4. So by looking for the overlapping area for these two inequality, eventually you can see that the area that we should shade is this one. Within the circle and also in the area that is above, okay, of the line that we draw. So this is actually the shaded area that fulfill these two regions. Okay, so now we discuss question number 3. Okay, so they give us a diagram, and after that they tell us that there's an equation. So this equation is x power n y power 2 equals to c, where the n and c are constants. So the graph of ln y against ln x. So you can see that they are sketching the ln y over ln x. It's a straight line passed through the point. So these are the points given as shown in the diagram. So they want us to find the value of n and also the value of c correct to 2 decimal places. All right. So if you look at this equation, generally we should know that this equation shouldn't be a straight line. All right. So that means they already try to modify the equation become a straight line equation. So from here, according to the diagram that they sketch, we know that you have to try to rephrase our equation in terms of ln y and also ln x. So first step, we are going to take ln for both sides. So we are having ln x power n y power 2 equals to ln c. Alright, so if I try to expand, I will have n ln x plus 2 ln y equals to ln c. And my aim is to rephrase my equation become y equals to mx plus c, where the y-axis should be ln y, where the x-axis should be ln x. Okay, so this is my final aim. Okay, I want to rephrase my equation like this. So from where I stop here, I will bring the ln x over. So it will become negative n ln x plus ln c. And finally, I try to bring the 2 over. So I'm having negative n over 2 multiplied with ln x plus ln c, then divided by 2. So from here, you can see that we are having the equation in the pattern of y equals to mx plus c. Okay, where this is actually a straight line equation. Alright, so to find the value for n, to find the value for c, and etc., what we need to do is like we have to apply. We have to use the information or the points given in the diagram, and we substitute it into the equation that we have here to get the value of n and also to get the value of c. So first of all, let us have a look for this one. This is actually the gradient, right? Negative n over 2 is actually the gradient. Therefore, from here, okay, maybe I write the answer here. So for the gradient, it is actually equals to negative n over 2. So how to calculate the gradient from the diagram? So from the diagram here, you can calculate the gradient by using the points. So let's say I'm having 1.21 minus 0.91, y1 minus y2 divided by x1 minus x2. So 0.31 minus 1.06. And it is equals to negative n over 2. All right. Okay. And from here, what we can do is like we can press the calculator and try to get the value of n. If you didn't do any careless mistake, the value of n that you get will be 4 over 5. Or you can rephrase it to 2 decimal places if you want, which is 0.80. So this is how we actually calculate the value of n. Right, so once we settle the value of n, now we want to continue to get the value of c. Okay, so to get the value of c, I might want to use any point that they provided just now, and we will substitute it into the equation to get the value of c that I want. Okay, so for this part value of c, I will try to write it here. Okay, so at the point, you can use any point that you like, either this one or the other point here. So for me, I'll just use the 0.31. 0.31 with 1.21. So this is actually the value of ln x, and this is actually the value of ln y. Alright, so I will substitute 1.21 equals to negative n over 2. So n is 0.80, like what we calculated just now. Then divided by 2, ln x. Ln x will be 0.31. Okay, and after that we are having plus ln c. So plus ln c divided by 2. Okay, all right. So if you try to move and simplify all the numbers, okay, and bring it to the other side, the value of half ln c that you get will be equals to 1.334. and the value of ln C will be equals to 2.668, and hence if you want to get the value of C, you have to bring the ln over, it will become the base E power 2.668. Okay, then by just pressing the calculator lah, then you try to get the answer in 2 decimal places. So for 2 decimal places, the answer for C should be 14.41. Alright, so if you didn't do any careless mistake, right? If you are not using this point, you use 1.06 and 0.91, it will also give you the same answer. Okay. Okay, so let us continue to question number 4. Alright, so they give us the parametric equations. So we are having x in terms of theta and also y in terms of theta, and they want us to show that the dy dx is equals to this expression. Alright, so to get the dy dx, okay, from a parametric equation, generally what we need to do is like we have to apply the differentiation separately, okay, for the equation of x and also the equation of y, and after that we have to apply the chain rule. To get the dy dx, generally you need to apply the chain rule where you need to use dy over d theta multiply with d theta over dx, okay, to get the dy dx. Right, so we will start from the first part first, where I want to find out the dx d theta. Okay, so we are having this equation, x equals to 1 minus cos theta. Okay, so if I want to get dx d theta, I want to differentiate this equation. Differentiate 1 is a constant, therefore you get 0. Negative, you copy it. Differentiate cos, you'll get negative sine. So I'm having negative sine theta. Alright, so negative multiply with negative, of course you have the positive sine theta. Alright, so this is my dx d theta. And the other equation is y equals to cos theta minus 1 over 4 cos 2 theta. Okay, so to get the differentiation for dy over dx, dy over d theta, differentiate cos will have negative sine. So negative sine theta. Alright, so negative 1 over 4 is a constant, so we'll just copy it. Differentiate cos 2 theta, you have negative sine, then copy back the angle, which is the 2 theta. And after that, you need to further differentiate the angle. So differentiate 2 theta, we'll have a 2. So we multiply the 2 at the back. Right. Okay. And now I'm trying to simplify this term, this expression. So I'm having negative sine theta. And then negative multiply with negative become positive. So I'm having 1 over 2 sine 2 theta. Alright, so this is what I have for dx d theta and also dy d theta. Alright, and now I want to combine these two equation, these two answers together to get the dy dx. Alright, so let us start now. Okay, so to get the dy dx, I need to apply the chain rule. So dy dx is actually equals to dy over d theta multiply with d theta over dx. Okay, so what is dy d theta? So this is my dy d theta. So I'm having negative sine theta, okay, plus half sine 2 theta. Multiply with d theta dx. We are having dx d theta as sine theta. Therefore, if I want to get the d theta over dx, you have to make the whole thing upside down. So I'm having 1 over sine theta. Alright. So which means that if I multiply it together with d theta dx, so that means you can divide it by sine theta here. Alright, so in general, this is how I get the dy dx. But we need to rephrase it into the pattern that they want. So you can see that in the question here, right, our final answer is in terms of half theta, which means we need to further simplify it so that we can get something with half theta here. And then in the whole equation here, you can see that we are only having sine squared. All right, so we have to try and see how can we get to this part. Okay, so maybe we can start to have a look from our answer here. Because our final answer has half theta, so that means for me, right, I will try to expand maybe all the double angle to become a smaller angle. All right, okay, so let me start now. For the first part, negative sine theta divided by sine theta, I will have -1. If I split the fraction into two smaller fraction, okay, so I'm having half sine 2 theta divided by sine theta. All right, so if I want to continue further, then I'm having -1, then plus, I want to make the half in front. Okay, so for the sine 2 theta here, I can apply the double angle formula where sine 2 theta is equals to 2 sine theta cos theta and divided it by sine theta. All right, so again, maybe some of you will ask, why do I need to apply the double angle formula here? It is because of, in my expression, I'm having 2 theta, and my final answer, I only want to have theta over 2. So which means that we have to apply maybe multiple times, all right, the double angle formula to make it become a smaller angle, all right, and only we can get the answer in terms of theta over 2. All right, so if I continue further from here, so you can see that we can cancel off sine theta and sine theta together. And our answer will look something like this. Okay, and also 2 and 2 can be cancelled off. All right, so I'm having -1 plus cos theta. Okay, so let's continue further. How can I rephrase this term become the answer that they want? So from the answer that they want, we can see that they have something for sine squared. And in our step here, we are having cos theta. In the answer, we are having sine square and then theta over 2. Therefore, if I want to change the theta, become theta over 2, again, I will need to apply the double angle formula, where the basic double angle formula will look something like this. So we are having cos 2 theta. For the original double angle formula, right, it will look something like this. So 1 minus 2 sine square theta. Okay, so I try to link the cos with the sine square. So cos, we are having the sine square here. Okay, and because of, for our answer here, it is cos theta instead of cos 2 theta. Therefore, I can rephrase it again by changing the angle. So if I'm having cos theta, so the 1, you just copy the 1. 2, you just copy the 2, right? Sine square, also copy the sine square. The only thing that you need to change is the angle here. So please observe, when you're having 2 theta, and when you apply the formula, it becomes a theta. So if we have cos theta here, therefore when you want to expand it, the angle here should be equals to half theta or theta over 2. All right, so we are going to apply this double angle formula to continue in our steps. All right, okay, so I'm having -1. So from here you can see that cos theta is equals to 1 minus 2 sine square theta over 2. So if you further simplify it, you will see that we finally get the answer that they want us to show, where the dy dx is equals to -2 sine square and then theta divided by 2. Okay, so now we come to question number 5. All right, we are having angle alpha and beta where both of them lies between 0 to 180 degree. And then they fulfill these two equations. So this is the equation number 1 and this is equation number 2. So they want us to find the possible values of the alpha and beta. All right, so generally we are having two unknown here. Therefore, you need to use these two equations to solve for the alpha and beta. All right, so we will start from the first equation. So we are having tangent alpha plus beta equals to 2. And this is a double angle, right? So I'm going to apply the double angle formula. Oh, sorry, not to say the double angle, it should be a compound angle formula, okay, to expand this part. All right, so when I apply the compound angle formula, it will be equals to tangent alpha plus tangent beta divided by 1 minus tangent alpha and tangent beta, which is equals to 2. Okay, so I will leave this as my first equation. Of course, I can't solve the alpha and beta for now because we are only having the first equation here. We need to find out the second equation, okay, and substitute it into this first equation. So our second equation is very straightforward, where you can see that tangent alpha is equals to 3 tangent beta. So I will assume that this is my second equation. All right, I want to substitute equation number 2 into equation number 1. Okay, so equation number 2 is tangent alpha equals to 3 tangent beta. Tangent alpha, I will write it become 3 tangent beta plus tangent beta divided by 1 minus 3 tangent beta multiply with tangent beta, and it is equals to 2. From here, you can see that this whole equation, when I further simplify, right, this whole equation will have only the beta as unknown. All right, so I'm having 4 tangent beta divided by 1 minus 3 tangent square beta, and it is equals to 2. Okay, so further simplify it. All right, and try to rephrase it again. Eventually, you should able to get a quadratic equation in terms of tangent beta. I'm having 3 tangent square beta after I simplify it, then plus 2 tangent beta minus 1. It is equals to 0. When we are having a quadratic equation, you can, to solve it, you can factorize it if you want, or you can apply the quadratic formula. So for me, I will try to factorize it. When I try to factorize it, this is what I get. That should be negative 1 here and plus 1 here. And continue further, you will see that our tangent beta have two equations, two solutions here. So tangent beta equals to 1 over 3. Tangent beta equals to negative 1. Okay, then now from here, you can continue to solve for beta. So for this part, beta is equals to tangent inverse 1 over 3. So for tangent inverse 1 over 3, right, they give us a restriction where the beta should be between 0 until 180, which is the first two quadrants. So when you press for the calculator, right, this answer should be from the first quadrant, and the answer for beta in this part should be 18.4. All right, then we go to the second equation here. To get the beta, it will be equals to tangent inverse negative 1. Again, if you want to get the answer for tangent inverse negative 1, when you try to press calculator, what is the answer that they will give you? They will give you actually negative 45. All right. So if I want to get the correct answer that they restrict the beta is between 0 until 180, you have to ignore the negative sign and you take 180 minus the 45. Of course, there are many ways for you to find the answer in the second quadrant. I'm considering the second quadrant, the answer from second quadrant. It is because of tangent negative shouldn't from the first quadrant. It should be from the second quadrant. So to get the answer for the second quadrant, you take 180 minus the basic angle. All right, so I'm taking 180 minus 45 degree, and therefore I get 135 degree. So you can see we are having two answers for beta. So beta equals to 18.4, beta is equals to 135. We need to continue further to get the alpha as well. So to get the alpha, it will be equals to tangent inverse 3 tangent 18.4. All right, so by pressing calculator, you can get the answer for alpha. And for this part of beta, again, to find out the alpha, you will have tangent inverse 3 tangent beta. So the beta is 135. Press calculator to get the answer for alpha as well. If you didn't do any careless mistake when pressing the calculator, answer for alpha, this part should be 45, And the second answer for the alpha will be equals to 108.4. And then if you want, you can rewrite the answer again. When you're having alpha equals to 45 degree, your beta is equals to 18.4. Where if your alpha is equals to 108.4, then the beta will be actually equals to 135. So you can double check the answer here. Both alpha and beta actually fulfill what they want. So you can see that both alpha and beta, their range is within 0 until 180, where it is requested in the question at the beginning. Right, so this is how we solve question number 5. Question number 6. All right, so find the complex number W where it satisfies this equation and such that the real part of W should be smaller equals to 0. Okay, give your answer in terms of x plus iy where x and y are real. All right, so maybe you try to have a look for this equation first, and we actually need to get the value, the W. All right, so in terms of x plus iy, so from here you know that W is a complex number. And then there's one important restriction here where the real part of W is smaller or equals to 0. Okay, so let us try to define W first, where W is equals to x plus iy, right? Or maybe it is also given in the question where W can be written as x plus iy. And then real part of W generally means the x. So x is the real part. Iy here is actually the imaginary part, right? So real part of W smaller equals to 0 means that the restriction here is x should be a negative value. All right, so smaller equals to 0 means x should be a negative value or x can be a 0. Right, so we already know that W is x plus iy. Then in this equation, we are having W star or asterisk. So W asterisk means that it is the conjugate of the W, the complex number W, where it should be x minus iy. Okay, so we'll start to solve this equation now and try to find out the x and also y from here. All right, so we are having W squared plus 2i W asterisk equals to 1. What is W squared? W squared is x plus iy squared. 2i, I just copy 2i. W asterisk means x minus iy, which is the conjugate of W, and it is equals to 1. We need to expand this bracket. When we try to expand it, we are having x squared plus 2xyi plus y squared with I squared. This part, you multiply in the 2i into the x and also 2i here. We are having 2xi minus 2y with I squared, and it is equals to 1. This is I squared. Okay, so maybe I write clearer. This is actually I squared, not negative 2. It looks like negative 2, right? I'm having I squared. And please take note that I squared can be written as a value negative 1. Okay, we have to substitute I squared as negative 1 here. 2xyi. If I squared is negative 1, so this term will become negative y squared. If I squared equals to negative 1, this term will become positive 2y, and it is equals to 1. Alright, our equation now will look something like this. And what I want to do is I will try to group all the real part together and all the imaginary number together. For the 1, I will move it over, become negative 1. If I want to rephrase, right, all the real part without the I. So x squared is the real part without the I. Negative y squared is also the real part without the I. 2xy Sorry, I think I made a careless mistake here, right? Oh, so this one should be 2xi, not 2xy. 2xi. Sorry for that. Okay. So we're having 2xi here. This is imaginary number I don't want. So 2y, I will just include in my real part. 1, when I move it over, become -1. It is also a real part of this complex number. So this is a real part of my complex number. For the imaginary part, I'm having 2xyi and also 2xi. So I'll have 2xy plus 2x, then I. And it is equals to 0. From here, very obvious, I will have two equations. I can form two equations where the first one I will use this. So for the imaginary part here, 2xy plus 2x, the coefficient is equals to 0 because on the right hand side, everything is 0, right? So the complex number coefficient here, it will be 0 as well for the imaginary part. When I want to solve it, right, I'm having 2x, then y plus 1 equals to 0. And if I solve, x will be equals to 0, then y is equals to -1. All right, so we cannot stop our answer here because the x and also the y is not the final answer. These are actually two solutions, two different solutions. Therefore, you have to further solve for the y from x equals to 0, and we need to further solve for the x at the part where y equals to -1. So you have to aware that these two answers is not one set of answer. They are two separate sets of answer. Okay, so I will further simplify it and solve it for the x and also the y. So when x equals to 0, I want to use the real part, okay, of my complex number to solve it. So when x squared equals to 0, I'm having x squared minus y squared plus 2y minus 1, and I let it equals to 0 as well because on the right hand side there's no real part. Okay, the real part is equals to 0. Since the x squared is equals to 0, so I simplify this equation, it will become a quadratic equation again. And then when I try to factorize it, eventually I'll get one answer where y equals to 1. So this is considered as one set of complete answer. Like when x equals to 0, y should be equals to 1. So our second set of answer will be when y equals to -1, what happened to the x? What is the value of x? So I'm still using the same result here. X squared minus y squared plus 2y minus 1 equals to 0. And then from here, substitute y equals to -1 into the equation. Eventually, I will get x squared equals to 4. And my x equals to plus minus 2. And from here, we have to make a decision. So from here, we only accept the value where x equals to -2. And we will ignore x equals to +2. All right, because of what? Because of in the question, they request that the real part of w should be smaller equals to 0. Real part of w means the x. Smaller equals to 0 means that they only want to consider the negative value. All right, so we ignore the positive value for the x equals to 2. We are having the second set of answer here. And we want to rewrite it into the pattern of the complex number. So what is our w here? So the w will be x plus yi. First set of answer, x is equals to 0, y is equals to 1. So our first answer will be w equals to I. And the second answer will be x equals to -2, y equals to -1. So when you write it up, it should be equals to -2 minus I. So this will be the two complete answer for the complex number w. Okay, so let's discuss question number 7 now. So part A, by sketching a suitable pair of graph, they want us to show that this equation has exactly one root in this interval. So the keyword will be one root here. and then in this interval. So by sketching a pair of graphs, so when we want to sketch the graph, we should consider two graphs that is from this equation. You can consider to sketch 4 equals y equals to 4 minus x squared. Another equation that you can try to sketch is y equals to secant 1 over 2x. Alright, so please take note that the secant 1 over 2x here also can be written as 1 divided by cos half x. So you just draw the reciprocal function for the cos half x, then you will get the secant half x graph. Alright, so if I want to look at it in detail, to get 4 minus x squared, original graph will start from x squared first, where it is actually a U shape that pass through the 0, 0. Next step will be when you multiply a negative, you are reflecting the graph, okay, through the x-axis, and therefore your U shape will become the N shape. And finally, if you want to get 4 minus x squared, that means that you are trying to translate this whole graph 4 units up. So 4 unit ups means that the maximum point will stop at 4. So this is actually the 4. Okay, and because of the interval given, it is from 0 until pi. Therefore, later when you want to sketch it, we will only consider the part of the graph where I start from 0 until pi. This is what you have for 4 minus x squared. For secant half x, to sketch the secant half x, you need to sketch the original graph of cos half x first. To sketch the cos half x, generally the original graph will look something like this. This is the 1. So my cos graph will go down and touch the 0. And at this point, it should be a pi. Okay, because of we are having the half x here. Therefore, when it touch the 0, it will be at the x value, the x value which is pi. And this is cos x. So when I want to sketch 1 over cos x, this is the minimum point at the 1 will become, this is the maximum point at the 1, and it will become minimum point at the reciprocal function. This is a 0 in cos. So when you want to draw the reciprocal function, right, the 0 here will become infinity because 1 divided by 0, you'll get infinity, where the line x equals to pi will become the asymptote. So your curve for the secant half x should look something like this. And please take note that this is 1. So if you combine these two graphs together, generally our final graph will look something similar like this. Okay, so maybe we're having a 4 here. Alright, so you can label this as y equals to 4 minus x squared. Okay, and after that, if you want to label it clearer, right, the x-intercept for the y equals to 4 minus x squared should be a 2. And the pi should be after this x-intercept. Alright, so for the pi here, we are actually having the line where this is pi. Okay, so maybe I draw it again nicer. Okay, so this is actually the pi. Sorry, wait. Okay, so this should be a U shape. My U shape might not be so nice. Okay, right. Then after that, for the pi here, it should be an asymptote. And then for my secant half x, right, the minimum point is a 1. So maybe I can label the 1 here. And the line pi is asymptote. Therefore, if I sketch the curve, it will look something like this. It will get very, very close to the asymptote, but it will not touch the asymptote. So this is the graph for y equals to secant half x. Okay, all right. So maybe I can label it y. This one should be y equals to secant and then half x. Okay, so we already sketched the graph, a pair of graph. Then to prove that it has one root in the intersection, right? We are actually looking for the intersection point. So how many intersection points between these two curves here? You have only one intersection point. And from here, you can make a conclusion where one intersection point can be seen. One intersection point can be seen in this range, all right? Therefore, you can make a conclusion that there is exactly one root for the equation of 4 minus x squared equals to secant half x in the range or in the interval of 0 until pi. Okay, because you can see there's only one intersection point for this part. All right, so this is how we actually sketch a curve and also how to make the conclusion by looking at the intersection point. All right, then we can proceed to part number 2. Okay, so for part number B, they want us to verify by using the calculation that this root actually lies between 1 and also 2. Okay, so to prove that this root lies between 1 and 2, right, we need to refer to the original equation first. So we are having the original equation where 4 minus x squared equals to secant half x. And to verify by calculation, I need to change the equation become a function where you can have an option. Either you move all the terms on the left, move it to the right, or you can move all the terms from the right and you can move it to the left, up to you. So for me, I'm going to move the secant square over, become negative secant half x. Okay, so I want to prove that the root lies between 1 and also 2. So to prove this, I will substitute 1 into the function f. So when x equals to 1, what is the value for the function f that I have? So we can have a look here. Okay, so you have to make sure that when you want to press for the calculator, right, your calculator should be in radian mode. Again, you have to ensure that your calculator should be in the radian mode because of this one. We are having something that is related to the secant, the trigo, okay, the angle in trigo. Therefore, to ease the process of the calculation, we will set the calculator into the radian mode. Okay, so I need to press shift setup, right? Okay, so which is a 4. So I will change it become the radian mode first. And I want to get the value for this function at f1. Okay, so I'm having 4 minus 1 square. X square means 1 square. Then minus secant half x. So secant half x will be equals to 1 divided, or you can actually make it as a fraction, right? So 1 divided by cos half x. Half x means that when x equals to 1, you substitute it here, you have a half. So you can press in 0.5 cos. And you press equal sign. This is the answer that they show us in the calculator, where you should get 1.86 if I make it into 3 significant figure. So we do the same thing for f2. Okay, so what I need to do is that I need to try to change the value here. So the 1 here, I will change it become 2. And then for the secant, the part here, okay, when you multiply the 2 inside, so you have secant 1. So secant 1 means you're having 1 over cos 1. And you press equal sign again. The value that you get will be negative 1.85. All right, so you can see that f1 is equals to a positive value and f2 is equals to a negative value here. So we can see the sign change, okay, between these two answers. And we can make the conclusion now. Sign change can be seen. Between F1 and F2. And the conclusion is the root lies between x equals to 1 and also x equals to 2. So it is necessary for us to make the conclusion here. Okay. Then now maybe you can proceed to part number C. Okay, so for part number C, since we already know that the root lies between 1 and 2. Okay, now they want us to use the iterative formula. The iterative formula is given in this question. This is the iterative formula that they want us to use it. Okay, to determine the root correct to 2 decimal places. So final answer should be in 2 decimal places, but all your iterations should be 4 decimal places. Okay, so for this equation, for this question, they already give us the iterative formula. This is the iterative formula. Okay, and then now we want to get all the iteration until we get the root. The initial value for this case, they actually didn't suggest any initial value. Therefore, you can decide ourselves. All right. So how to decide it? There's a small suggestion here, okay, or small technique that you can use, where you can try to use any value that they ask you to prove in the part B, the previous part. So like for part B in this equation, right, in this question, we already know that the root lies between 1 and 2. Therefore, for the initial value here, you can use any value, either 1, either 2, or any value between 1 and 2. All right. Okay, so this is a small suggestion. Or you can refer to actually the answer here. Okay, so you can see which value actually will give you this answer, okay, which is close to 0. Okay, F1 is equals to 1.86, F2 is equals to negative 1.85. So I will assume that maybe F1.5, the answer that I get should be maybe close to 0. All right, so for me, in this question, I will use 1.5 as the initial value. If you don't want to use 1.5, of course, you can use any other value, such as 1, 2, or any value between 1 and 2. If you want to try your luck, you can use also the values that's outside this range. All right, so you still can get an answer. You might still get an answer, just that maybe your iteration will become longer. Okay, right, so we will start here. So my initial value is x equals to 1.5. What will be my x2? So to get the x2, I actually need to substitute the 1.5 into my iterative formula, where it is equals to secant half 1.5. Okay, and we can press the calculator for this. Let's have a look for the calculator again. We need to key in the equation here. Okay, so for this part, we are having square root, so I will key in the square root, and then 4 minus secant. So for the secant part, I will use a fraction here, where secant is equals to 1 over cos. And then the angle inside the cos is actually half x. So what I will do is like I will key in the x, and then this is 2. Then close bracket. So this equation is actually 4 minus secant half x. All right, and again, please make sure that you are putting your calculator in radian mode. Right, so now you want to get our iteration. Initial value will be equals to 1.5. So what is the second value for the x? So to get the second value of the x, you press on calculate on your calculator. They are asking what's the value for x that you want to put in. So you just key in 1.5 and you press equal sign. So this is actually the second value that we get for the x, which is 1.6 227444242. But this is not my final answer yet. It is considered as the iteration. So to write out the answer for iteration, you have to restrict it to 4 decimal places, where it should be equals to 1.6227. All right, so I want to get the third value for the x, the next iteration value, where I will now key in 1.6226, oh sorry, 1.6227, right? I will actually insert this value of x into the iteration formula again. So let's have a look for the calculator again. All right, so just now we already get 1.6227, right? Okay, so I want to continue the calculation. Therefore, I just press the calculate again. Then they will ask us what's the value of x that we want to key in now. So the second value that we want to key in now for the x is 1.6227. All right, so I'll just type in 1.6227 and you press the equal sign. So the next iteration value will be 1.5961. So in the answer here, I will write as 1.5961. So I will try to repeat this iteration until I get some values that is very close to each other in 2 decimal places. Okay, or maybe you can check lah. For this one, 2 decimal places is 1.62. For this equation, for this value, 2 decimal places will be 1.60, where 1.62 and 1.60, they are not the same yet. So these two are not the roots yet. So you can continue for the next iteration to find out the x4. So to find the x4, you have to key in, insert the 1.5961 into your iterative formula. So let us start again. Press calculate and then key in the value 1.5961 and press equal sign. And this is your next iteration where it is equals to 1.6024. Okay, so I'm having 1.6024 to 4 decimal places. Then you check again for this answer, right? What is the answer for 2 decimal places here? It will be 1.60. And you can see that these two values are actually the same, repeated. Okay, so you can see that 1.60 for the 2 decimal places. This is also 1.60 for 2 decimal places. Okay, so we actually can conclude that the root is 1.60. If you want it to be safe, you can maybe try to extend it to another iteration if you want. Just double confirm that your final answer is correct. All right, so again, just to confirm, I press calculate again. I key in 1.6024 and press the equal sign. Okay, so the next answer will be 1.6010. Oh, sorry, 1.6009. So in my iteration here again, I will write 1.6009. And if you double check the answer for 2 decimal places, it will be also equals to 1.60. So I think it is good enough here, and we will stop here. We can make the conclusion where the root is actually equals to 1.60, correct to 2 decimal places. Okay, so again, when you want to press the calculator for this part of the question, right? First, you have to make sure that your calculator is set in the radian mode. That's the first thing. And secondly, you have to ensure that when you write out the iteration, right, every single iteration here should be correct to 4 decimal places as requested in the question. And after that, you also need to double check, okay, for all the answer for 2 decimal places, and you can stop the process for the iteration once you realize that your 2 decimal answer are repeated. Then you can stop. All right, so for this question, the final answer for the root will be equals to 1.60. Okay, so we discussed question number 8 now. Right, so they want us to find the quotient and remainder for this when the polynomial is divided by 4x squared plus 1. Okay, for me, I will want to use the long division method, okay, to get the quotient and remainder for this part. All right, so I'm having the long division where 8x power 3 plus 4x squared plus 2x plus 7. and then for the divisor will be 4x squared plus 0x plus 1. Okay, so when we want to start the differentiation, the long division, generally what we do is like we will refer to the first term, okay, of the polynomial and also the first term of the divisor. So something, okay, the quotient, part of the quotient is here. So something multiply with 4x squared to get 8x power 3. So what's the something here that I should put in? Right, so I should have 2 times 4 become 8 and then x, so that x times x squared become 8x power 3. Right, so once you decide that this is 2x already, besides multiply with the 4x squared, you also need to multiply with the second term, which is 2x multiply with 0x, and you are having 0x squared. Okay, then 2x multiply with 1, then you are having 2x also. Right, so we continue from here. 4x squared minus 0x squared, you get 4x squared. 2x minus 2x becomes 0, and 7 minus 0, you get a 7. Okay, so if you rewrite again, this one will be 4x squared plus 0x plus 7. So now we can continue again and see whether can we continue for the next long division or not, for the next level. Okay, so I'm having 4x squared and refer to the 4x squared here. Something multiply with the 4x squared to get the 4x squared. So what is the something here? So the something here should be plus 1, right? So 1 multiply with 4x squared, I'm having 4x squared. 1 multiply with 0x, you get 0x. And then 1 multiply with 1, you get a 1. So you minus all the terms here, 4x squared minus 5 squared becomes 0, 0 minus 0 still 0, 7 minus 1 becomes 6. Alright, so you realize that we cannot continue anymore, alright, for the long division, so we will stop here. And of course, we should know that this is actually the remainder for the 6, and the terms, the expression on top will be the quotient. So we can write it again. The quotient will be equals to 2x plus 1, and also the remainder will be equals to 6. Okay, and then we should know also like for this long division, right, if you want to express the whole question here in a equation, generated equation can be formed will be px uh, equals to, or we can write as this, px divided by divisor. When the polynomial divided by divisor, what we will get is actually the quotient plus remainder over divisor. Okay, so this is a general formula that we have when we apply a long division, and also we want to rephrase it into an equation. So this is what we have here. All right, so if I want to apply this equation into our example here, all right, polynomial will be 8x power 3 plus 4x squared plus 2x plus 7 divided by the divisor. So what's the divisor here? Should be 4x squared plus 1 equals to quotient. So the quotient will be 2x plus 1. Remainder will be the 6. And then the divisor will be, again, 4x squared plus 1. All right, so usually for any long division, if you want to express the answer, right, in an equation form, generally, this is how we can write it out. All right, where polynomial, again, divided by divisor equals to quotient plus remainder over divisor. So generally for this example, we are having this equation. Okay, so why is this equation important? Because we might need to apply this answer in part B later. All right, but of course, for this question number 8, part A, you just need to focus on finding out the quotient and remainder. All right, okay, so let's continue to part number B. All right, so for part number B, they actually want us to find out the integration for this expression. All right, then there's one important keyword here, which is the exact value. So that means exact value means that your final answer, right, must be in either the surd form or pi form or fraction, but you cannot put it in a decimal places or in the long decimal place number, right? Okay, so if we have a look for this one, the question here, and we try to link it with part A. So you can see that actually this part, this part of the question, right, is actually similar to what we did just now in part A. So you can see that if we compare this and this together, it's actually what we did in part A just now. Part A just now. All right. Yeah. So you can see that they are the same actually. Okay. Therefore, when you want to apply or when you want to go through for the integration for this question, generally I need to use this result, okay, to continue with the integration. So how are you going to do that? Let's start now. Okay, so let me copy the question first. I'm having 0 and half, then 8x power 3 plus 4x squared plus 2x plus 7 and divided by 4x squared plus 1. Okay, then since I already rephrased my equation just now, okay, as quotient and remainder answer. All right, so we are having the quotient and also remainder divided by the divisor. So I'm going to change this one and replace by this. And I'm having 2x plus 1, then plus 6 over 4x squared plus 1. Okay, and then next one, you need to try to integrate all this. When integrate all these things here, generally it is not hard because 2x is just a simple term. So when you integrate 2x, you will get x squared divided by 2. So cancel off the 2, you have x squared. Integrate the 1, you will get the x. Okay, so now I want to integrate this part. Okay, 6 is a constant, therefore I just copy it first. Now I'm going to integrate the 1 over 4x squared plus 1. Okay, so for 1 over 4x squared plus 1, to complete or to carry out the integration, right, there's one formula that we can use, which is very useful. And you can get this formula from the formula booklet. All right. Okay, so now this is a formula booklet. This is a formula provided by the formula booklet. Then if your function fx is like this, so after integration, this is what you will get. So we are having the same pattern here actually. Our question is we are having 1 over 4x squared plus 1. And I want to integrate this. Okay, before I integrate this, I will try to make it into the same pattern here. So you can see that the coefficient of the x squared is actually a 1. Therefore, if I want to make it as a coefficient 1, I will actually factorize out the 4 from the x squared and also the denominator. All right, so I will want to factorize out the 4. So my denominator becomes x squared plus 1 over 4. Okay, so to fulfill the pattern of the formula that the x squared start with coefficient 1. So now I'm having x squared start with coefficient 1. Okay, then next step, I'm going to rephrase it into the pattern of x squared plus a squared. So I'm having x squared plus, how to rewrite the 1 over 4 become a squared. So the a will be actually 1 over 2. So that 1 over 2 squared, it is 1 over 4. Okay, then we can straight away apply the formula here. 1 over x squared plus half squared, where this is what we have for the function. After I do the integration, I'll get 1 over a. So 1 over a means that 1 over half, because my a is equals to half here, right? Then I'm having tangent inverse, so you just put tangent inverse x over a. So we are having x over a. So my a is again half. Then I try to simplify this. 4 divided by half, 4 multiplied with half. So at the denominator part, you are having the half here. Okay, so which is 1 over 2. Then I'm having tangent inverse x divided by half. If you simplify it, you have 2x. Which means now if I do the integration for this expression, the final answer that I get will be this one. And now I would like to replace, substitute this answer into my steps. Okay, so to substitute this answer into the step, my step will look something like this, where it will become 6 multiplied with half, and then tangent inverse to x. Then I want to substitute the value later by using 0 and half. Okay, so again, before I apply the substitution into the step, I will want to simplify this term first. 6 multiplied with half, I'm having 3. So I'm having 3 tangent inverse to x. Okay, so when the whole equation or expression looks much more simplified, then only I will try to substitute all the value inside. Okay, substitute the half into x squared, I will have 1 over 4. Substitute the half into the x, I'm having half. And then substitute half into this, you will have 3 tangent inverse 1. Then minus, if you substitute 0 into all the terms here, right, the whole expression is actually a 0. Okay, then by just pressing calculator, you will have 3 over 4 plus 3. So tangent inverse 1 will give you the value pi over 4. Okay, so you can just keep your answer in this way. All right, which is the exact formula, 3 over 4 plus 3 over 4 pi. Or you can factorize out the 3 over 4, then you get 1 plus pi. Okay, don't change your answer into the decimal places, because for this question they are requesting for the exact value. So when you see the word exact value, it means that your final answer should be in the pi form, or maybe in the third form of fraction, where don't write it out in decimal number. Okay, so this is how we actually solve for question number 8. Now question number 9. We have the differential equation. So the differential equation is given, and then they give us some useful information here, where when x equals to 1, y also equals to 1. Okay, so they want us to solve the differential equation and also find the exact value of y. So again, you highlight the word exact value. Okay, when x equals to 3. So giving your answer in the simplified form. Okay, so this is a differential equation question. So let's start. We will need to use the technique of integration, right? So I'm having x plus 1 and 3x plus 1 dy dx equals to y. Okay, so first step, I have to move all the x to one side and all the y to one side. Okay, I will keep the dy here on the right, sorry, on the left, and then the dx will be on the right. Okay, so when I move the y over, it will become 1 over y. When I try to move all the terms out with the x over, it will become 1 over x plus 1, and also 3x plus 1 dx. Okay, so once I successfully separate all the variable y on left hand side, all the variable x on the right hand side, then I can actually start to apply the integration. Okay, so for this one, if you want to do the integration, it's very straightforward. You will get a ln y. But for this expression here, for this fraction here, generally we need to point out the partial fraction first before we can continue with the integration. So let us start the process of finding out the partial fraction. Okay, I'm having 1 over x plus 1 and also 3x plus 1. Generally, I can rephrase them become a over x plus 1 and also b over 3x plus 1. So this is because we are having very basic linear factor. Alright, so we are having these two partial fractions, and we want to find the value for a and b now. Okay, so to find the value for a and b, I will want to make the denominator disappear. Therefore, I multiply the whole equation with the denominator. So I'm having 1, and then a 3x plus 1 plus b x plus 1. Okay, so by referring to maybe for this first for this bracket for the bracket x plus 1, I want to substitute a value of x so that this bracket becomes 0. So I will let x equals to -1. When I let x equals to -1, I substitute the -1 into this whole equation with the x. So I'm having 1 on the left. So -3 plus 1 is -2, and having -2a. And therefore my a is actually equals to -half. Okay, then now I will refer to this bracket 3x plus 1, and I want to make it become 0. So I need to let x equals to -1/3 so that this bracket will become 0. Right, so after I decide the value for x equals to -1/3, again substitute it into the whole equation here. Okay, so I'm having 1 on the left hand side. Substitute here, it will become 0, so a disappear. And then substitute -1/3 into this part, you will have actually 2/3 b. And therefore the b is actually equals to 3/2, right? And of course you can rewrite this again. So what's the answer for this? What's the partial fraction for this fraction? You will have -1/2 x plus 1, and then plus 3/2 3x plus 1. Okay, and again, this is an important result that we will need to use it in the integration later. Okay, so once we already find out the partial fraction, we can continue with our step here. Okay, I'm having integration of 1/y dy equals to, okay, I will substitute this partial fraction answer into the fraction here, and I'm having -1/2 x plus 1, then plus 3, 2, and then 3x plus 1. Okay, so we can start with the integration for now. All right, so for me, usually before the integration, I will actually prefer to take out all the constant. So what's the meaning of taking out all the constant? That means for this particular term, right, I will actually take out the -half. Then it will become 1/x plus 1. Then plus, for this term, I will actually take out 3/2. And I have only 1/3x plus 1. Okay, and then only I will start the integration. So to integrate this 1/y, I will get ln y, ln modulus y. Okay, so -half is a constant, I just copy. Then integrate this part, I will have ln modulus x plus 1. Okay, then plus 3/2, because 3/2 is a constant, so you integrate this. When you integrate this one, you have ln 3x plus 1. And after you differentiate the 3x plus 1, you have a 3, right? Therefore, you have to divide this term by 3. Then I'm having a plus c here, where the constant I can decide it by using the values that we given just now. Okay, so further simplify it. So when I further simplify, I'm having -1/2 ln x plus 1. Then for this one, 3 and 3 can be cancelled off. I'm having 1/2 ln 3x plus 1 also, then plus c. Okay, so just now they give us a very important value. When x is equals to 1, then y is equals to 1, right? So when x is equals to 1, y is also equals to 1. Substitute all this value into the equation just now to get the c. So I'm having ln 1 equals to -half ln 2 plus half ln 4 plus c. Okay, and please take note that ln 1 here is actually equals to 0. Therefore, your c is actually equals to 1/2 ln 2 minus half ln 4. Right, then if I want to further simplify it, here you need some knowledge on the properties of the logarithmic function. All right, so I can take out the half. When I take out the half, I'm having ln 2 minus ln 4. So ln 2 minus ln 4, if I combine that, it will become ln 2/4. And further simplify, I'm having C equals to half ln 1 over 2. Okay, so I already get the value for C. Then now I want to answer the question. The question wants us to find out the exact value of y when x equals to 3. Okay, so when you get the value for C, that means you already solved the differential equation. So if you want, you can rewrite it again. That means your differential equation will be equals to ln y equals to negative half ln x plus 1 plus half ln 3x plus 1 plus c. So it is half ln half. This is actually your differential equation after you get the constant term c. Okay, and then for this question, generally you no need to rephrase the answer become y in terms of x because they didn't request for this. Okay, so you can just keep your differential equation like that. And after that, we will continue to the next part where they want you to find out the value of y. And please take note, the value of y must be in exact value. So they are saying that when x equals to 3, what is the exact value for y? Okay, so I want to find out the y, right? So I'm having ln y. Substitute all the x by 3 in your equation. So you're having negative half ln 3 plus 1 is a 4. Ln 3x plus 1. 3 times 3 is a 9. So 9 plus 1, you get a 10. And then plus half ln half. So to get the value of y, right, now you need to get rid of the ln. And before you can get rid of the ln, you have to try to simplify and gather all the terms on the right hand side. Okay, so what can we do now is I'm trying like this. So I'm taking like this. I'm having ln y still. And then I will factorize out the half. When I factorize out the half, okay, I'm having ln 10, which is positive. Ln half is which is positive. So when you're having the positive means that you can multiply them together. I'm having ln 10 multiplied with half. When you are having minus ln, that means you are dividing. So I need to divide it by 4. So again, this involves the properties of the logarithmic functions. So you need to maybe go and do some revision on this part. Okay, then I further simplify it. I'm having half still. Okay, so 10 divided by 2, you get a 5. I'm having 5 over 4. Okay, and then for any constant in the log function, right, you can pull it, you can actually try to pull it become a power for the number itself. And we are having ln 5 over 4 power half. Okay, so now how can we simplify further? 5 power half means square root 5. 4 power half means 2. All right, and now you are having ln y equals to ln square root 5 over 2. And you can cancel off the ln straight away because both sides only have a single term. Okay, only have one term, and both terms also have ln. All right, so you can cancel off the ln straight away. Therefore, your final answer for the y will be equals to square root 5 over 2. So this is the exact value for the y. Okay, so I hope you can understand. And here we end our question number 9. Okay, so we come to question number 10. We are having the points A and B with the position vector shown here. Then the line has vector equation. Okay, so they want us to find the vector equation for the line through A and B. Right, so to find the vector equation for the line that pass through the A and B, we need to have the direction of the line. Direction of the line means that we are having A here and we are having B, right? Okay, so the direction of the line can be AB, or if you want to find out BA also no problem. All right, okay, so that's the direction of the line. Okay, so we will find out the direction of the line first. For me myself, I will use I want to find out AB lah. Okay, so in this question, they actually give us the position vector for the A and also the B, which means that your OA should be equals to 2, 1, 1, and your OB will be equals to 1, negative 2, and 2. Okay, so if I want to find out the AB, it will be AO plus OB, where it will be equals to negative 2, negative 1, and negative 1, plus the OB, which is 1, negative 2, and also 2. Right? Okay, then we should have negative 1, negative 3, and 1. Right, so if you are trying to find out the BA just now, for now I'm finding out AB. So if we want to use BA as the direction, then you will get 1, 3, and negative 1 for this answer. Okay, then we want to form the vector equation. So to form the vector equation, the general formula will be actually R equals to A plus dp, right? Where the A is the passing point of the line and the P is the direction of the line. So for the passing point that I'm using here, you can use either the point A or point B. So for me, I'm using point A, which is OA. OA is 2, 1, 1 plus T, and then P will be the direction of the line. So the direction of the line that we found out just now is AB, right? So we are having negative 1, negative 3, and also 1. All right, so this is the vector equation, okay, for this question. All right, so of course for this question, the answer, we have a lot of different answer. As if some students are using the BA as the direction, then this part will become 1, 3, and negative 1. And then you might also use B as the passing point here because the line pass through A and B, right? So besides the A, you can also use the B if you want. So if your answer is 1, negative 2, and 2, it is not wrong as well. All right, so this is the suggestion of the answer that I show here. So we ended part A. Okay, then now we continue to part number B. All right, so for part number B, let's have a look what they ask. Okay, so they want us to find the acute angle between the direction. Okay, so acute angle between the direction of A, B, and L, giving your answer in degrees. Okay, so this is the vector equation for the line L. All right, so I will rewrite again. For the vector equation of the line L, it is actually equals to R, and then what is the passing point? So the passing point is 1, 2, negative 3. 1, 2, negative 3 plus mu, then 1, negative 3, and 2. So mu 1, negative 3, and 2. Oh, sorry, and negative 2. Okay. All right. So now, if I want to find the acute angle between the direction of A, B, and also the L, to apply the formula of finding out the to find out the angle, right? We have to use only the direction of the line, which means that I will use this direction of the line L and also the direction, okay, of the line AB to find out the angle between them. All right, so I only focus on the direction of each line. Okay, so we are using the formula how to find out the direction the acute angle between two straight lines. Generally, you can use PQ. Okay, P dot Q equals to modulus P modulus Q cos theta. Right. So let's start. P dot Q. So maybe I assume this as P and this is Q lah, right? The direction. So I'm having negative 1, negative 3, 1, multiply with 1, negative 3, and negative 2. And it is equals to the modulus of this vector. So the modulus for this one will be negative 1 square plus negative 3 square plus 1 square. Multiply with the modulus for this direction as well, where you are having 1 square plus negative 3 square plus negative 2 square. and then multiply with cos theta. So the theta here will be actually the angle, all right, between the two directions. All right, so I apply the dot product. I'm having -1 plus 9. -1 multiplied with 1, you get a 1. -1. -3 multiplied with -3, you get 9. 1 multiplied with -2, you get -2. Okay, and then I'm having square root 11 and also square root 14 followed by cos theta. Okay, so to find the cos theta, generally I need to just bring everything over. All right, so I'm having cos theta equals to 6 divided by square root 11 and also square root 14. Therefore, to get the theta, you just take cos inverse. And very easily, by pressing the calculator, your theta should be equals to 61.1 degree. So in this question, they already mentioned that we want to have the answer in degree. So the level of accuracy for the degree answer should be to 1 decimal place. So the answer will be 61.1. Okay, just in case, all right, just in case, if just now when you try to use some different direction, okay, for this one, maybe when you use different direction, if you get this value as a negative value, then when you are trying to press the calculator, please make sure that you ignore the negative value. It is because of, for this question, they are asking for acute angle. So for acute angle, when you take cos inverse, right, to get the acute angle, it must be positive. Okay, all right, so you can just ignore the negative, but just in case if you get a negative value for this dot product, all right, so when you want to find out the theta, when you want to find the theta, just make sure that you ignore the negative sign in this case. All right, so this is what we have for part number B. Okay, then now we continue to part number C. Okay, so for part number C, they want us to show that the line through AB does not intersect the line L. Okay, they want us to show, all right, so line AB does not intersect. So does not intersect for with the line L, and this is the 3-dimension, right? Okay, which also means that they want us to show that they are skewed line. Okay, so how can we prove that they are skewed line? Okay, so first I need to try to equate these two vector equation. So for the line AB, this is the equation that we have, the vector equation that we have, and we want to equate it with this one. All right, okay, so I will let AB equals to L. So when I put them in the bracket, it will look something like this. So the line AB will become 2 minus t, 1 minus 3t, and also 1 plus t. And it is equals to line L. So 1 plus mu, 2 minus 3 mu, and -3 minus 2 mu. Okay, from what we show here, right, we actually can get three equations where 2 minus t equals to 1 plus mu is the first equation. Okay, from the first equation and the equation from the dimension x. Then the second equation you can have is 1 minus 3t equals to 2 minus 3 mu. And then the third equation will be 1 plus t equals to -3 minus 2 mu. All right, so to solve the value for t, to get the value for t and mu, right, you just need two equations. All right, so from these three sets of equation, you try to choose any two of them and solve for it. All right, so to my convenience, I will choose the first one, 2 minus t equals to 1 plus mu as the first equation. And after that, I will choose the last one as a second equation, and I want to solve them. So 1 plus t equals to -3 minus 2 mu. And I will put it as a second equation. To me, these two equations will be easier to solve simultaneously. All right, so what I do is like I will take the equation number 1 plus the equation number 2. When I take equation number 1 plus equation number 2, on the left hand side, the t disappear and I have a 3. 1 plus negative 3, you get a negative 2. Mu minus 2 mu, you get a negative mu. Therefore, very easily, I can get the value for mu, which is negative 5. Okay, if I get the value of mu, which is negative 5, then very easily also I can get the value of t. You can substitute the value of mu into either one of these two equations. All right, then you should be able to get the t, which is equals to 6. Okay, so after you solve these two equations and you get the value for mu and t, how can we show that these lines are actually skewed or do not intersect? Okay, if the lines are intersect, that means that when we want to put the value of mu and t into all the equations, the value should be the same. All right, but if let's say that there's one set of the equation, when you substitute the value into the equation and you didn't get the same answer from the left and the right hand side, that means they are skewed. So now I want to check and I want to just justify okay, whether that they are not intersect. Okay, so for me, I will substitute the value that I get, mu equals to negative 5 and also t equals to 6 into the equation that I never used just now. All right, so which is the equation that I never used just now to solve for the mu and t? So I'm substituting it into this equation. 1 minus 3 mu equals to, 1 minus 3t. 1 minus 3t equals to 2 minus 3 mu. Okay, all right. So I substitute t into the left hand side. So left hand side is 1 minus 3t, right? t is equals to 6. And I get negative 17. For the right hand side, I try to substitute mu. So 2 minus 3 mu. Mu is negative 5. And I get negative 13. I get 17. Sorry, positive 17, right? Okay, so from here, very obvious, you can see that the value from the left hand side and also the right hand side are not the same. So left hand side is not equals to the right hand side value. Okay, which means that these two lines actually do not intersect. If they intersect, right, when you substitute the value into this equation, both left hand side and right hand side value should be the same. But now we're having the value not the same. Therefore, you can make a conclusion where the line truth A and B does not intersect the line L. Okay, so we have to make a conclusion because of the reason that the left hand side value is not equal to the right hand side value from what we prove here. Right, so this is how we solve the question number 10. Okay, so we have now come to the very last question for this paper. Okay, so they give us a diagram and it shows that the curve is y equals to sine x cos 2x for this range, for this domain. So x is actually from 0 until pi over 2 and the maximum point at m. Okay, so they want us to find the x coordinate of m, giving your answer correct to 3 significant figure. Okay, so it is related to the maximum point. So when we want to find out the maximum point for any equation, right, we actually have to apply the differentiation. Okay, so we are having y equals to sine x and then cos 2x. Okay, so when I want to apply differentiation here, very obvious, you can see that they are product of two different functions, right? So this is the first bracket sine x and the second bracket will be cos 2x. Okay, so when I want to apply the product rule, differentiate the first bracket first. So differentiate sine x, I will have cos x. Then I copy the second bracket. Then plus, now I do the other way around. That means I copy the first bracket, which is sine x, and I try to differentiate the second bracket. So differentiate the second bracket, differentiate cos, I'll have negative sine 2x. And after that, I need to differentiate the thing inside the bracket for the cos, which is 2x. So differentiate 2x, I'm having a 2. Okay, so when I try to rephrase it, I will have cos x cos 2x minus 2 sine x sine 2x. Okay, to get the maximum, the x coordinate for the maximum point, after we find the dy dx, we need to let it equals to 0. And we have to solve for this equation. All right, so to solve for this equation, maybe I need to think a way, all right, whether can we rephrase it into some equation, or can I rephrase it into an equation that I can have the similar terms to be factorized or not. All right, so for me, what I plan here is I will try to expand the cos 2x and also to expand the sine 2x, okay, by using the double angle formula, so that I can try to factorize out some similar terms, all right, after I expand it. Okay, so for cos 2x, right, so for cos 2x, what I try to substitute is I will substitute 1 minus 2 sine square x. So you can get this formula from the double angle formula provided in the formula booklet. And then for the sine 2x, I will expand it also by using the double angle formula, which is 2 sine x cos x. Okay, again, if I try to rephrase everything again, try to expand and rephrase everything, I will have minus 4 sine square x cos x. All right, so from here, if I try to rephrase and simplify, I will have negative 6 sine square x cos x. So when come to this step, you can see that there's a similar term, right, which is the cos x for the whole equation here. So I will factorize out the cos x, then I will have 1 minus 6 sine square x. All right, so when I try to expand the formula by using the double angle formula on top, generally my main idea is when I try to replace it, okay, with the double angle formula, what I want to have is the similar term to be factorized. So when I factorize out the similar term, then I can solve it separately. So I'm having cos x equals to 0, and then 1 minus 6 sine square x equals to 0. Okay, so I will try to solve for the value of x. So when I solve for the x here, it will be pi over 2. And from the diagram, very obvious that we know the pi over 2 will not be the answer, okay, for the point M. The pi over 2 will be maybe the minimum value, the minimum point. Okay, therefore, pi over 2 will not be the correct answer. Okay, and then I have to solve this equation for the x coordinate for M. All right, so I'll rephrase everything again. So I'm having sine x equals to plus minus square root 1 over 6. Okay, and I will ignore the sine x, which is equals to negative. Okay, I will ignore sine x, which is equals to negative. It is because of, from the diagram again, you can see that the answer is between 0 until pi over 2. So between 0 until pi over 2 should be in the first quadrant, where in the first quadrant, sine should be positive. All right. Okay, so by pressing calculator, you take sine inverse square root 1 over 6, and you'll get 0.421, correct to 3 significant figure. So the x coordinate for M will be equals to 0.421 radian, okay, for 3 significant figure. So this is how we actually solve for the x coordinate of the maximum point M. All right, then now you proceed to part number B. Okay, so for part B, they want us to use the substitution of u equals to cos x, find the area of the shaded region. So when you see area of the shaded region means that you need to apply integration enclosed by the curve, and also the x-axis in the first quadrant. Give your answer in the simplified exact form. So please highlight the word exact form. Okay, that means your final answer should be in either the third form or in terms of pi or in fraction. All right. Okay, so to apply the integration to find the area of the shaded region, they actually want us to find the shaded region enclosed by the curve and the x-axis in the first quadrant, giving your answer in the simplified form, which means that we actually want to find out this shaded area, right? Because the diagram already showed us this shaded area. So to find out the area here, generally we need to know what is this x coordinate. Okay, so we need to know this x coordinate so that it will become the limit in our integration. All right. Okay, so we will start now. Okay, so original equation that I have here should be y equals to sine x cos x. Sorry, sine x cos 2x. And when I want to get the x coordinate, okay, or x-intercept, I will let y equals to 0 for the original equation. From here, I will have sine x equals to 0. Another equation will be cos 2x equals to 0. Okay, so for this part, I will have x equals to 0 and also maybe the pi where I should ignore it. As I know from the diagram, right, the value of x for the x-intercept that I want to find out is not equals to 0. So that means the answer should be in this equation. So I try to solve for the 2x. So cos inverse 0, I will have pi over 2. And therefore for the x here, I will have pi over 4. So this is the x-intercept that I want to find out. All right, to become the limit, okay, to become the limit of the integration later. All right, okay, then now, since for this question, they already hint us to use the substitution method for the integration. Okay, they want us to substitute u equals to cos x. All right, so I will let u equals to cos x. For the substitution method, I need to find out the differentiation for this equation. So I will want to have du dx. So du dx will be differentiate cos x, I will have negative sine x. Therefore, du will be equals to negative sine x and dx. And I will need this substitution later when I apply for the integration. Besides this, okay, so I will want to continue for the integration part. Okay, so to find out the area of the shaded region generally will be integrate something towards dx. So what's the limit here? From the diagram, you can see that the limit, the area start from 0, x equals to 0, and then x equals to pi over 4. The area is covered by this value of x. Okay, then the integration will be sine x and cos 2x. All right, so when I want to apply the substitution method for this integration, besides this, besides substitute this equation into my solution here, I also need to consider the limit because all these limits are for the value of x. Therefore, I will try to find out when x equals to 0, that means the lower limit here, when x equals to 0, what is the value for the u? So you substitute 0 into here, you're having cos 0. So cos 0 means u equals to 1. And for the other limit, when x equals to pi over 4, what is the value for the u? So substitute pi over 4 into the cos. You will have the value which is 1 over square root 2, or you can rewrite it as square root 2 over 2. Okay, so once you have all the details for the substitution already, then you can continue with your solution. All right, so we want to find out the shaded region. Okay, so I substitute the 0. I will change it become the value of u, which is the 1. Pi over 4, the value of u will be square root 2 over 2. All right, then for the cos 2x, for the cos 2x, right, I will still write it as cos 2x. Sin x, I will join it together with dx. And because I want to have negative sine x dx to substitute it by using du, therefore I need to add in or multiply in a negative here. Okay, so when you multiply a negative inside the equation, you have to multiply outside also somewhere in the equation so that the equation are balanced. Right, it is still the original equation, just that we multiply the negative, okay, in this phrase, in this term, so that we can substitute it by using the du later. Okay, so this part I can substitute by using du. And how can I try to substitute cos 2x by using du as well? All right. Okay, so maybe for this step, because I haven't changed everything into du yet, maybe I will just rewrite it again as the original value first. Okay, so negative, I just copy it as negative. Pi over 4, I still copy it as pi over 4. So for this cos 2x, I need to try to link it, okay, and expand it into the equation that is related to cos x. So for cos 2x, this is a double angle formula. I can rephrase it become 2 cos square x minus 1. Okay, then negative sine x and dx. Okay, so seems like everything is ready here. Then I will try to change everything into the u, the value of u, and also the terms in terms of u. So pi over 4 again, it is pi over 2, square root 2 over 2. When x equals to 0, the u is equals to 1. 2 cos square x, you can rewrite it become 2u squared. Because cos x is equals to u, therefore 2 cos square x will become 2u squared. Minus 1, you just copy it as minus 1. Negative sine x dx, you can see here, negative sine x dx is equals to du. Therefore, you can change it become du. So from here, right, this whole equation, you can see very clearly that you have changed your original equation, or in terms of x, already become the equation that is in terms of u. And from here, you can start to apply the integration. And you can see that this is a basic integration actually. Integrate 2u squared, you have 2u power 3 divided by 3. Integrate negative 1, you have negative u. And you want to substitute the value of square root 2 over 2 and also the 1 into the equation. Okay, so the negative is still outside. When you're having square root 2 over 2 and you take it power 3, all right, so for me, right, I will personally factorize out the 2 power 3 first, and the u power 3, I will rewrite it as square root 2 over 2 power 3. And when I try to expand it, or when I try to simplify it, it will become square root 2 square root 2 over 8. Right? Then minus the u means minus square root 2 over 2. Okay, then minus again, you are having, substitute the 1 into the equation, you are having 2 over 3 minus 1. Okay, so you just need to be a little bit more careful so that you won't do any careless mistake here. Okay, simplify this term, you have 4 divided by 8, you get a 2 at the bottom. So you're having 1 over 6 square root 2 minus 1 over 2 square root 2. And for this one, after you simplify all the terms here, you have plus 1 over 3. Alright, so you try to take 1 over 6 square root 2. That means 1 over 6 apple minus half apple. Okay, then plus 1 over 3. Eventually, you will have 1 over 3 2 minus 1 over 3. After you simplify it, you have to multiply the negative inside. Okay, so this is generally our answer lah. Or you can rewrite again by factorize out the 1 over 3. Then you have square root 2 minus 1.